Hi, welcome back to my channel. In this video, we're going to talk about how to multiply monomials and polynomials together. In other words, a monomial, which is a single term, multiplied with a binomial or polynomial. So multiplying it by two or more terms that are being added or subtracted together. Okay, so if you have not subscribed to already, go ahead and do so right now. If at any point you find anything here that is useful, go ahead and click the like button. That lets me know that this video was useful to you. Have something to write with and paper so you can keep up with our notes, and let's get to it. So here we have three examples of multiplying. Okay, notice how we're dealing with a monomial here, a single term multiplied by a binomial. So we're multiplying one single term times two terms. Same here, a monomial with a binomial. And here we have a monomial times a trinomial or a polynomial because there's two or more terms. So let's begin with this first example. We'll start gradually increasing the difficulty, and yeah, as we get to the end, you'll get a really good grasp on how to multiply any monomial to any binomial or trinomial. So here, when we see the parentheses, what we're really doing is multiplying. Right? We have 6 times 4a. So we're just going to distribute, use the distributive property that we discussed before. 6 times 4 is 24. And since there are no variables multiplying each other, we're just going to bring that a and tag along in the back. 24a. Then we multiply 6 times positive 3. And that is positive 18. So we're just really multiplying a monomial with two different terms. Here, very similarly, we multiply a negative 7 times 11. That gives us negative 77. C. There's no variables attached, so we just attach that C at the very back. And then negative 7 times negative 4, that changes to positive 28. And since these two terms are not like terms, we cannot combine them together. Now, this is more of a review, right? 1 and 2 have been a review of distributive property. We're going to take the same idea, and if you look at here at number 3, we're going to multiply it times a trinomial or a polynomial because there's more than two terms. So as we multiply the coefficients with each other. 2 times 7 is being multiplied together to give you 14. But at the same time, we're multiplying m times m cubed. This single m technically has a 1 as an exponent. Now, if you go back to our previous video on multiplying exponents, what do we do with the rules of multiplying exponents? When you're multiplying variables, you're going to want to add the exponents. So we have 1 plus 3, and that gives us 4. So in the end, we're left with m to the 4th power. We're going to add the exponent of this single term times the exponent of this other term, and when you combine these m's, we get to the 4th power. Similarly, we're going to multiply the 2 times the 5, and that gives us positive 10. And then the m with the 1 power times m to the 2nd power, when you add the exponents, you should get 3. So we get m to the 3rd power. And now here at the very last expression, we're multiplying the 2m times a negative m. And technically, in front of that m, we have an imaginary coefficient of 1. So when you multiply the 2, you're really multiplying it 2 times negative 1, which gives you negative 2. And then m times m, since they both have a 1 as an exponent, when you add them, you get m squared, or m to the 2nd power. Notice how none of these are like terms because this one's m to the 4th, m to the 3rd, and m to the 2nd, so we just leave this expression as is. So as you distribute, multiply the coefficients and add the exponents for the variables that are like terms. Let's try a few more examples. Here we're going to get into some more complex examples. Okay, now we're involving multiple types of variables. We're going to distribute into both terms, and we're going to multiply the variables that are in common. Now, whenever I see a variable with no exponents, I like to put a 1 here at the top to remind me that I have x to the 1 power and y to the 1 power. So let's distribute. 7 times 5, that's 35. When I'm multiplying the x's, x times x squared, we're going to add the exponent. So 2 plus 1 gives you x cubed. Since the y is multiplying also, y times, there's no y value, we just tag it along where we were at the back. In the next term, we have a 1y squared technically right here. So we distribute 7 times negative 1. That gives us negative 7. The x, as it's being distributed, x times, there's no x value, so we just tag the x along. But we do have a y value, so y times y squared, since there's one y here and 2 in the top, 2 plus 1 exponents, we get y cubed. And notice how these two are completely different variables with exponents. Here we have x cubed y, and here we have x y cubed. So since they're not identical, we cannot combine the 35 and the 7. We just leave them as is. So we distribute, multiply the coefficients, and add the exponents. Let's give these other ones a try. So feel free to press pause, work out this problem yourself, and then see if you get the same answer as I do. So 1/2 times x gives us 1/2 x. 1/2 times positive 8 is positive 4. Here, as I distribute this minus 3, I have to distribute all of this. So negative 3 times negative x changes to positive 3x. Negative 3 times negative 1 changes to positive 3. The negative will always change the sign, right? Over here, we're multiplying a positive 2. So 2 times 7 is positive 14. X, and 2 times negative 2 gives us negative 4. When you distribute, the parentheses disappear, and they are not there, right? So now we can look at the like terms and see which ones we can combine together. So this x value, we have an x value, and we have an x value. Those are like terms, so we can combine those coefficients. If you're struggling with fractions, right? If you struggle with fractions and how to add them to whole numbers and the rules of combining and least common multiple and all of that, just put it in your calculator. Press half plus 3 plus 14. Okay? That's going to give you, let's see, 14 plus 3 is 17. And when you add the 1/2, that's going to give us 35 halves. X. And then I'm going to look at the numbers, right? The numbers that I'm dealing with is, let's change colors here so you can see it. Positive 4, positive 3, negative 4. When you add all those together, you get 4 plus 3 is 7. 7 minus 4 is positive 3. And since these two terms are not like terms, one has an x and one does not, we leave the answer as is. And that's pretty much it, right? You want to distribute into the parentheses. If you're multiplying variables with variables, you add the exponents. Otherwise, you just multiply the numbers. Let's try one last example. Let's put this application to use. Here we're trying to find the area of a rectangle that has the length of 3x cubed y and the width of 2xy plus x to the 5th. So to find the area of a rectangle, we want to remember that area equals length times width. So what we're really saying here is I want to multiply 3x cubed y times 2xy plus x to the 5th. That's really what I'm saying. Length times width. Since I'm multiplying a monomial times a binomial, I want to distribute. So I multiply. 3 times 2 gives me 6. In the process, x cubed times x. I have a 1 imaginary here, right? So 3 plus 1, I get 4. So that gives me x to the 4th power. Same thing with the y. I have y times y. I have 1y and 1y here as an exponent, so 1 plus 1 gives us 2, and that's y squared. And then I go to the second term in the back. Now I want to multiply times the last term. So there's an imaginary 1 here in front. 3 times 1 is just positive 3. But what we can multiply is the x cubed times x to the 5th. Remember, we're adding the exponents. So 3 plus 5, I get x to the 8th power. And when we multiply the y across, since there's no y in the back, y times no other y, we just bring the y back where it is. We tag it along. And these two terms are not like terms at all, right? This one has x to the 4th, y squared. This one has x to the 8th and y. So I cannot combine these any further. And that's pretty much it. Here we're reviewing a lot of the rules of multiplying exponents, right? What do we do when we multiply? We add the exponents. Feel free to go watch my other video called Rules of Exponents Multiplication. Even division, we subtract the rule for division. If this video was useful to you in any way, go ahead and click the like button, subscribe if you haven't already, and as always, we'll calc you later.